Ladies and gentlemen, good morning and welcome to MFTG. Today I would like to share with you some of the recent progress in meaningful type game theory, that's MFTG. The agenda now in the next couple of minutes is to describe you a class of MFTG in the context of distributed power network, distributed power systems, distributed energy systems. So this is the setup. We consider three classes of decision makers, and those are consumers, prosumers, and producers. So by producers, we mean producers and distributors all together. So all the entire production distribution network. By producer, we mean those who produces and consume at the same time. Means when they produce more than what they did, they put that in the market. And by consumer, we mean the classical consumers, right? So these are the decision makers, and consumers want to be satisfied. Means they have a certain demand. For example, you look at your monthly bill and you have your consumption there, right? You want to be satisfied, but at the same time you want to reduce your bill as much as possible, right? That's the objective of the consumer. The prosumer want to produce electricity energy for its own need, but if there is an extra, you want to take opportunity to put that in the market to earn some money, right? That's the prosumer objective. Of course, environmental issues need to be considered here for environmental goals. So the operator, the producers want to satisfy the demand, and demand is not known in advance, and by producing. So producer has a certain power plant, has a certain production capability, but limited, and they start producing in advance by doing some forecast of the demand. So the forecast has, of course, a forecast error. It's not that perfect, unfortunately. So that creates some uncertainty, right? And the production has an uncertainty because the power plant have some dependencies, external, internal dependencies, and so on. And there are a lot of uncertainties there, weather uncertainty, and so on. So we consider, for example, solar energy power plants, wind energy power plant, hydro power plant, and so on, and nuclear power plant. So the four categories of them, for example, right? And so the producer need to reduce the mismatch between demand and supply, but also need to consider, for example, the variance between demand and supply. These are random, fine. As I said, demand is not perfectly known in advance, unfortunately. So there is an uncertainty there, and we want to reduce the mismatch between demand and supply, and reduce the variance. Then because of that, the outcome is of meaningful type, because variance is there. So we have variance awareness, means risk awareness is there. So we have a meaningful type outcome. Now, since we have multiple category of agent, multiple decision makers, this leads to meaningful type game, right? So we want to find meaningful equilibria, meaningful type equilibria in this context. We want to reduce the risk for each of the decision makers that are involved, and we want to find algorithms. We want to find design learning rules, find algorithm design incentives, so that we can find a situation where all these interacting agents have their equilibrium outcome, right? And if there are many, then selection or more or less efficient equilibrium. And if you look at the goal of the operator, for example, you will see that there are multiple possibilities to match a number, right? To match a demand. Given a forecasted demand, there are multiple ways of matching this. And this demand, as I said, is a forecasted one, is a random thing. And when they realize what happens, they realize one might be higher or lower depending on the situation. If it is lower, there is a loss because we don't have enough storage for that energy. If it is higher, if the production is higher, if the demand is higher, then we are not able to satisfy some of the demand, some of those demands because they wanted to get from prosumers might not be able to cover the rest, right? So that's the risk that the production is facing. This is a very interesting problem, very challenging problem, and some of these aspects have been solved in our distributed power network papers. You can find them online, and this is what I wanted to share with you today. Thanks you for your time, thanks for your attention, and see you soon on MFTG. Bye.